everyone. Let's continue our lesson from next subject. It is about the consideration in intraoral scanners. Let's talk about intraoral scanners. Intraoral scanner has been steadily developed since 1985, when the first patient was treated with this device at the University of Zurich, Switzerland. Professor Merman at the Dental Hospital and Brand Destiny at Polytech University introduced the first machine. The development of digital dentistry has been over 30 years, and the lack of clinical use is gradually disappearing. At the time of its introduction, inlay design consisted of multiple layers, lines, and not 3D graphics. Machining was also conducted with a limited form of discs. At present, many developments have been made. I have been working with University of Zurich on an ongoing basis. On the left side is a prototype of intraoral scanner CEREC at the University of Zurich Museum. And on the right side is a cheerful look after a heated discussion at Professor Merman's laboratory, the founder of the intraoral scanner. Professor Merman was awarded the Achievement Award at the first conference of the International Academy for Digital Dental Medicine, IADDM, in Zurich. 10 years ago, the intraoral scanner was big and heavy. Because the data were completed by image stitching, I had to hold my breath and push pedal cautiously to avoid shake image. There were many data distortions. However, recently introduced scanners are small and lightweight. It is easy, fast, and accurate enough to scan even the soft tissue. Even if the brackets are attached to the teeth, we can make a digital impression of the patient without discomfort. Intraoral scanner can be used as part of routine care. By accumulating data from the same patient on a regular basis, we can track changes such as gingival recessions, recurrence of malocclusion, and tooth wear. It varies depending on the scanner system. However, in a system whose data goes up to the cloud after scanning, we can access to the data anytime and anywhere, no matter where the equipment is. It's beneficial for communication between dentists and technicians. One of the difficulties in using intraoral scanners in the clinic is when the tooth margin is deep subgingival. The patient's maxillary premolar was fractured during chewing. I had to scan deep subgingival margin with bleeding. As you can see in the picture, the scan seems to be extremely difficult. Among the intraoral scanners, I use i500 scanner in my hospital. This system can additionally scan impression bodies instead of directly scanning poor areas such as bleeding teeth, bleeding gingiva, allowing us to take advantage of physical impressions. I can scan the impression body as an added scan, so you can modify the poor data, replace the poor data with a scanned data from physically made impression body. You may worry about the accuracy of intraoral scan data. I performed a complete arch scan of the phantom model with a precisely machined abutment teeth. You can see this article at the JPD Art Journal, which is a prestigious journal in the field of orthodontics. The difference in data accuracy is noticeable in full arch scans made from old intraoral scanner systems, such as E4D, intraoral scan, and plan scan. However, the recently updated trials, true definition I0 and I500 are showing good accuracy. If you look at the same position for each intraoral scanner, you can see that various aspects of intraoral structure are represented on the same tooth. Like the traditional method, there are various errors in the digital impression body, such as shown like in the photo pictures, as well as deformations of rubber impression body. We can see the deformations in the real impression body made from rubber impression material. Also, we can see the errors made by intraoral scanner systems. Therefore, when the clinician makes digital impression with intraoral scanner, he or she must check the digital impression data before transferring that to the design center. Some intraoral scanners accurately reproduce the situation in the mouth, but others do not. Fortunately, recently launched intraoral scanners have shown clear and accurate images. As you can see from I500 group, trials, and true definition, the margins are easily noticeable and the preparation shape is clear. Trueness and precision in each intraoral scanner, trials, I0, true definition, and fast scan groups showed significantly lower variance than the other groups in the trueness comparison. With the precision comparison showed the lowest deviation in trials and true definition I0 groups. The light source of the intraoral scanner is divided into two. Lasers are imprecise due to the speckle. It is true in theory, but the effects are too small to matter in practice, so you don't have to be worried. Most of the recently introduced intraoral scanners are based on light instead of laser. Intraoral scanners which utilizes laser for light source are shown like this. It includes I0 and plan scan. Most of the recently introduced intraoral scanners are based on light instead of laser, and those scanners are Trials, I500, CS3600. If you are a clinician with a digital impression device, the most common question is that if you make crown with intraoral scanner, you do not have to adjust the occlusion. Depending on the intraoral scanner, lateral bite scan is used to establish the upper and lower relationship, which may vary in accuracy. Of course, there is a difference in accuracy depending on the intraoral scanner system. Therefore, it is necessary to always check whether the occlusion has been created in the same manner as the actual mouth after the scanning. you can see the depth of the field. This is large and this is small, narrow. As the depth of the field is important when taking the patient's mouth, the patient's photograph, it is good if the depth of the field of the intraoral scanner is wide. In most cases, the scanning depth of the system is about around 13 millimeter. In case of iTero scanner, you can easily scan even when the scanner tip is close to the teeth. But the scanners such as Lava iOS, Lava COS, if you do not maintain the distance of 5 to 15 millimeters, such as when we hold the scanner apart from the teeth, the scanning process stops and it is difficult to resume the scanning, and you have to find the less correct position. So it's a learning curve is very difficult. Another aspect of the accuracy of the intraoral scanner is the maximum scan rate in reaching the deepest part of the preparation. I occasionally suffer from not being able to acquire the complete scanning at the narrow and deep inlay box or crown margin, which is next to the long adjacent tooth. Therefore, to evaluate these parts, I evaluated various intraoral scanners for complex inlay preparations. In the color map shown in the photo, the color of the inlay floor of E4D is red, and that of the intraoral ZFX in intrascan, the color is blue. Red color means that the scanned inlay floor is higher than it really is, and inlays made from this data may be thin and can easily be fractured. The blue color, the blue one is that it is lower than actually is. So the inlay that you make will be high, and you may have to adjust the occlusion. It may take significant time in the clinical situation. The interior trueness measurement may have been influenced by the complexity of the preparation. This may also have caused by the limited maximum range of which intraoral scanner can reach the deepest part of the preparation. So, and the availability of scanner head rotation in the patient's mouth. Yeah, this aspect is relative to the scanner's ability about focal depth. As you can see from the photos, the next adjacent tooth is erased for the easy view, and it is deepest. It is deep and narrow box, and it is not easy. It is difficult to scan with intraoral scanner. As you can see, some scanners cannot express the exact shape of the inlay box, but others can express it accurately. So you have to consider it when you are applying it to the inlay cases. If you come to use intraoral scanner, you will often produce a full zirconia crown with a model-free zirconia restoration. Will this treatment result in a restoration with good fit for clinical use? At first, crown is manufactured by changing the inner value parameter of the crown according to the degree of tooth preparation and the abutment inclination, which is various according to the dentist. In the clinical practice, the replica technique is used to analyze the internal fit of the crown. It is the shape of how to make a replica from the crowns. When comparing the marginal gap with a similar clinical study which I have done for modellessly produced monolithic zirconia crown from intraoral scanner, this measurement was good enough for the clinical application. This is one thing to consider when you make a model-free crown with an intraoral scanner. The margin of the crown is often overextended, like this. You can see the overextension pattern in the figure at the right side. It is overextended or over-contoured restoration. Usually, monolithic restoration is fabricated with CAD/CAM system, and it must have a certain thickness of margin due to prevention from chipping, while the margin of conventional casting crown is able to have knife edge. When we are making conventionally, the thin margin cannot be fractured easily, but when we use milling machine to cut the thin crown margin, there usually be a chipping. So we are designing this part thicker than actually is. And in the laboratory, as a result, in the laboratory, final trimming of the zirconia crown margin that is cut thicker than actually is. The margin is trimmed without model. So margin trimming is difficult without dye, and we cannot get a physical dye with intraoral scanner data. I am authorized to conduct clinical trials from KFDA for Korean-made intraoral scanner and trials, best-selling intraoral scanners in the world. And I started the clinical evaluation of these devices. As you can see from the clinical photos, I fabricated a monolithic zirconia crowns from the intraoral scan data from two devices. Marginal fit of an occlusion was evaluated and compared between two intraoral scan systems. Although the crowns were manufactured based on the intraoral scan data, marginal accuracy was good enough for clinical application. Internal and marginal fit was evaluated through the replica technique as shown in this slide. The various cases of clinical encounters were studied, and the crowns of two intraoral scanners could be evaluated one-to-one. I checked contact, margin, occlusion for each group, and they were clinically acceptable with good occlusion and marginal integrity. Because the crown is put on the patient's mouth, the specimen cannot be cut in half. For this reason, the indirect measurement using silicone indicating material was conducted. It is called as replica technique. As a result of measuring the internal interval by the replica method, there was no difference between the two intraoral scanner groups. The major margin of tooth number 24 is deep because of extensive subgingivally involved caries. we often give up acquiring digital impressions with intraoral scanners in those cases. But I could scan this case because of the new feature of intraoral scan system. Scan data was improved by impression at scan features. And clinicians must know that the margin may not be clear when we examine the intraoral scan data, and often we have to turn on and off the color feature to discriminate between the actual abutment tooth structure and gingiva. But in case of implant restoration, it is much easier to capture digital imaging with intraoral scanner because there is not a physical margin to read, and we only have to capture the shape of scan body, which is a replica of impression device. After acquiring data with scan bodies, we can design and manufacture restorations and models with 3D printer. It is photos of restoration, provisional and final restorations. The clinical accuracy, field accuracy is good enough for clinical application. Marginal field was around 50, from 40 to 50 microns. When you scan the patient's mouth, he or she may have such much saliva in the mouth or blood bleeding over important areas such as margins. Let's see how the intraoral scan data changes. The tank was filled with was filled with water at various levels to compare the actual depth of the pulpal floor with the scanned depth. Just as the coins in the pond appear to be closer than they actually are, if you fail to remove saliva before you acquire an intraoral scan from the abutment teeth, then you may get data that differs from the actual depth. It is important to inspect important areas after scanning because the blood is recognized as color as added to the scan data. As you can see, the blood is also captured as a structure, so you have to inspect the data before transferring this data to the design center. Most of the currently available intraoral scanners can be sufficiently used in our daily practice, but the application to the full arch, complete arch case should be carefully considered because of the arch distortion. Because we have to put the intraoral scanner in the mouth, the optical window of the scanner is small. The images obtained through this narrow optical window are reassembled. So in this process, the distortion of the image may occur. Fortunately, the latest intraoral scanners have recently upgraded the scanning software, improving a reconstruction algorithm which automatically corrects or reduces the amount of distortion. To evaluate the distortion problem, I designed the full arch model with 6 geometric cylinders and spheres and printed out into metal master phantom. From this, I could create coordination system and measure the amount of distortion at each segment. Evaluated intraoral scanners included the brand new systems. I used the extremely accurate industrial scanner to acquire reference data. Scanning strategy of each group, intraoral scanner group, was followed by manufacturer's instruction. With this phantom model, we can evaluate the amount and direction of distortion. In this way, we can check the critical point to consider when selecting the appropriate intraoral scanner. The result of this evaluation is accessible at the journal named +1. And I made a Korean standard about the intraoral scan performance evaluation. So you can download the data from KDA, Korean Dental Association website, and you can use it to evaluate the same process. The International Dental Show was held in Cologne, Germany. I could find convenient functions such as caries detection, built-in smile design from various companies, intraoral scanner companies. I evaluated the performance of the intraoral scanners introduced at IDS 2019 and posted the result on Facebook. This was also introduced in a guidebook written by the Korean Academy of Digitalized Dentistry. One of my research projects is to evaluate the currently introduced latest scanners using this model to assess the most significant vulnerability of intraoral scanners, which is the distortion of the arch. I made a unique attempt to introduce this phantom design to each scanner manufacturers. There is an SCIE journal called JOV, that is a journal that introduces the research process as a video. I experienced in this journal I explained this journal how the model is measured as a video in detail, shown in this video. In this regard, I'm working as a Korean expert in the Digital Dentistry Division of International Organization for Standardization, ISO. Here I'm evaluating the validity of the standards that are being developed. I conduct the international experiments such as milling accuracy, milling machine, and give an opinion on the shape of the implant scan body. It is the last slide. Scanner companies are continuously upgrading their software capabilities and are adding additional features to leverage scan data in a variety of ways. After I scan the patient's mouth with a brand new intraoral scanner, data is automatically uploaded to the cloud, and platforms like smartphones, App Store will provide us various applications to take advantage of convenient features such as smile design and auto creation of provisional teeth. From this lesson, you could get some grasp of intraoral scanners and its characteristics. Good work, and let's continue from next lesson. Thank you.